Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Anggun Engla Kagia Putri Harza. I'm a student from Universitas Pendidikan Indonesia. I will present the result of potensi to overcome misconception by using multiple representation on the concept of chemical equilibrium. Chemistry is based on concept. A lot of material is abstract and therefore it's difficult for students to understand and learn it. To be able to understand chemistry thoroughly and deeply, students must be able to connect the multiple representation. In general, students have difficulty connecting microscopic and symbolic knowledge with submicroscopic knowledge, so there will be many misconceptions. When students convert their knowledge to the submicroscopic level, some of the cause of misconception are due to phenomena that cannot be observed, abstract concepts in chemistry, and operating mathematical calculation. Many misconceptions in chemistry are caused by the inability to visualize structure and process of the submicroscopic or molecular level, whereas a large part of chemistry learning and involved microscopic and symbolic level. Relevant research was conducted by Demrichaku 2030. Demrichaku report misconceptions that occur in students among others. Students consider those related to reactant and relate product by simple arithmetic relationship. They assume that the concentration of the product is the same as the concentration of the reactant under equilibrium condition, and students express their belief about the comparison of equilibrium that accurate the forward and reverse reaction will change. Learning that connect properties of matter submicroscopic level with other level macroscopic and symbolic level is effective in helping students make connection between the three levels in chemistry so that their understanding is better. Multiple representation play an important role in the teaching and learning of chemistry. Therefore, to be able to understand the concept of chemistry as a whole, multiple representation must be connected. Next method. In this study using research and information collecting research stages. The first step taken is the analysis of article. Article collected by searching through a Google Scholar search regarding misconception contained in the concept of chemical equilibrium obtained 40 articles that explain the misconception that occur. And review the literature on multiple representation in the general chemistry textbook. After that, the second stage is reviewing the literature on multiple representation of the concept of chemical equilibrium in the general chemistry textbook to overcome the misconception that occur. Analysis of article regarding misconception of chemical equilibrium material. In the review article, 14 articles discuss misconception. The focus of this article is on the equilibrium system. The rate of forward reaction is not the same as the rate of reverse reaction. This misunderstanding is the focus here because it's found in every 40 article analysis. This misconception is a problem for a student described in the article where the student inability to analyze abstract chemical equilibrium concept. And review the literature on multiple representation of chemical equilibrium material in the general chemistry textbook. In the concept of chemical equilibrium, many students still think that in the equilibrium system, the rate of the forward reaction is not the same as the rate of the reverse reaction. After reviewing several general chemistry books can be seen in this slide. Basically, this chemical concept will be easily resolved by understanding macroscopic representation. The use of representation in various ways to representation of phenomena is called multiple representation. To overcome student misconception in chemical equilibrium, namely in the equilibrium system, the rate of the forward reaction is not the same as the rate of the reverse reaction. Will be explained based on the phenomena summarized in the multiple representation below. In closed container, hydrogen gas and iodine gas are put into the summer container at a certain temperature. 1 mole of colorless hydrogen gas reacts with 1 mole of purple iodine gas. When hydrogen gas and iodine gas fall to a container, there was the same volume and the temperature. The origin of the color produced from the gas mixture in the cylinder is a purple. As shown in Figure C, the purple color produced because the gas mixture contained a compact iodine gas in a purple. Over time, the resulting purple fades. This is because the iodine gas in the cylinder is reduced. Iodine gas is reduced because it reacts with hydrogen gas, which forms a colorless hydrogen halide gas. Microscopic hydrogen iodide was not formed initially, so that in the top there were only hydrogen gas and iodine gas. Whereas in Figure B, the color intensity of the gas in the top fades. This is due to the formation of colorless hydrogen iodide gas. From the above experiment, Figure A is a mixture of hydrogen gas and iodine gas in the initial state. After stirring for a while, a mixture of gas iodine, hydrogen gas, and hydrogen iodine gas produces a fat purple color. The result is purple in a fixed intensity type as a grade B, Figure B, and Figure C. They saw that 3 is still iodine gas in this cylinder, in other words, the reaction between hydrogen and iodine gas. The formed hydrogen iodide gas has increased the equilibrium, which is indicated by a fixed color. With the following reaction equation, hydrogen gas reacted with iodine gas produces hydrogen iodide equilibrium. The state of equilibrium occurs when the formation of hydrogen iodide gas from hydrogen gas and iodine gas occurs simultaneously with the decomposition of hydrogen iodide gas to hydrogen gas and iodine gas again. Product substance, hydrogen iodide gas, and reagent, hydrogen gas and iodine gas, which have reached equilibrium, have a fixed composition, or do not increase with time. This can be seen in the number of gas molecules contained in the table Figure B and Figure C as matched. Unchanged concentration can indicate that in equilibrium state there is a component of a reagent and also component of a product substance. That is the reason why the resulting purple color is still observed with a fixed intensity over time. Next, conclusion. In this article, a misconception that discusses the reaction rate is not the same as the reverse reaction rate. The real concept is chemical equilibrium reached when the rates of the forward and reverse reaction are equal and the concentration of the reactant and product no longer change with time. This can be proven by a phenomena based on many representation. This phenomena is an example of the elaboration of concepts that have been described in the form of multiple representation to overcome misconception about chemical equilibrium. Okay, this is the result of my article presentation, and thank you.